So our next example here is, what if we have a small sample? If we have a small sample, we can't use a normal curve. That's the reason why we start out with our five-step model. And the first step is if n is greater than or equal to 100, right? So let's start with this example, right? The example from the PowerPoint. Do families that reside in the center city have more children than families that reside in the suburbs? Okay, so let's just start out with our five-step on this, right? So do families that reside in the center city have more children than families that reside in the suburbs? So, and let's look at what we have, right? So our sample size is 42 for our sample number one. So sample number one, sample size is 42, and for sample number two, the sample size is 37. Okay, if we add these up together, we get 9 and 79. They are definitely less than 100. That means that we can't use a normal curve and we don't have to use a t-distribution, right? So that's step number one of our five-step, right? Step number two of the five-step says, what kind of test is this, right? So it reads, do families that reside in the center city have more children? More children. So we instantly know this is a one-tail test, right? Because it says more. And we know that our hypothesis for this is and the null is basically, that they don't, right? Our alternative hypothesis is that they don't, right? So there's a different formula. It's the same basic process. It's just you have to incorporate more numbers. It's still just basic math, right? So the formula for this is this formula. It's still step one and step two. Step one, we find the pool of standard errors, right? And for this particular one, it looks kind of big and nasty, but it's not really that bad. It's sample size number one times the standard deviation squared of sample number one, it's supposed to be a one, plus sample number two times the standard deviation squared of sample number two over n one, the sample size number one, plus sample size number two, minus two. And we'll multiply that by sample size number one plus sample size number two, multiplied by n1 times n2. So it looks kind of encompassing, but it's not that bad, right? And step number two is that we'll just plug this into our z-obtain formula, which is sample number one minus sample number two divided by the pool of standard errors. But there's an additional step here, and this is step number three, because this is a small sample. Since it's a small sample, step number three requires us to find degrees of freedom. For this case, degrees of freedom is simply sample size number one plus sample size number two minus two, right? Okay, so we're following that five step. This is actually step number three. Step number two would be the level of significance. We're not given one for this example. Since we're not given a level of significance, we use we'll use the social science accepted one, which is an error of 0.05 or alpha of 95%, which equates to a z-score of 1.96, right? Okay. So in the next slide, we'll actually do the actual problem.